Hey guys, welcome back. Today we are jumping into our first part of our exercise set here in 1.1 of Chapter 1, where we were discussing points, lines, and planes. So let's go ahead and jump straight into our exercises. And we'll begin here with our vocabulary. So question number 1 is asking for an example from your classroom of 3 collinear points. So let's remember that collinear means on the same line. So anywhere where you can see 3 things lined up perfectly straight would be an example. So for example, you could write down 3 corners along the edge of your desk, or the points where 2 floor tiles meet across the floor. That's in our possible answer here from the text. But you also could give other examples, maybe 3 nails along one edge of a bookshelf, or the tops of 3 pencils standing on their tips in a row. These are all examples that we can give for number 1. All right, now let's take a look here at number 2. We're going to make use of the fact that endpoint is a compound of end and point, and name the endpoint of segment ST. So the word endpoint is made of 2 smaller words, end and point. So an endpoint is literally a point at the end. Now let's look here at ray. This is a ray ST. Now order matters in rays. Our first letter is S, which means that is going to be our endpoint. If we were to label that, it would look like this. And it is important with rays that we follow that correct order. So S is our endpoint. All right, let's go on to 3 through 6. We'll be using this figure to answer. So for example, 3 wants us to use the figure to name 5 points. A, B, C, D, E work just fine. They work just fine here. So we can write A, B, C, D, E for our answer. And number 4 is asking for 2 lines. So one possible answer is line AC and line BD. So there is a line here in the figure that goes through points A and C with arrows on both ends. That is line AC. There's another line that goes through points B and D with arrows on both ends. Line BD. So we're tracing both lines on the figure and putting arrows on the ends, and then we can write next to our question here, line AC and line BD as such. Now there are other correct answers that exist, for example, line BC, line CD, etc. But these are the 2 that the textbook are giving, so let's go with that. Number 5 says 2 planes from the same figure. So plane A, B, C. There's our script letter. So plane A, B, C, plane N. Those are certainly options there. So maybe we'd want to write plane next to that. Plane ABC, or plane with the superscript, or not superscript, but fancy script here, N. This is going to be plane N as well. Number 6, a point on line BD. So we're looking at the figure again, and line BD goes through B, then C. Then it goes there to D. All 3 of those points are on line BD, so any one of B, C, or D would be the correct answer. So B, C, or D. All right, let's go to our next part. Draw and label each of the following. A segment with endpoints M and N. So let's remember with our segments, we have 2 dots. One here we have labeled M, and the other labeled N. So we can draw a dot, label it M, another dot to the right, label it N, and then connect them with a straight line. No arrows on our line segments. And above the drawing here, we can write M, N, and with a bar on top to show that these do not go forever in both directions. This is a line segment. This is segment MN. All right, so a line segment with two endpoint dots labeled M to the left and N to the right are joined by a straight line, MN. Now we also could label this segment NM. Both work. Order does not matter in our segments. What about a ray with endpoint F that passes through G? Now, order does matter. We need to make our endpoint F there because this is going to be ray FG. Let's label that FG with, and I don't even need the dot there. Just draw the line with the arrow. There we go. Line FG. Ray. Ray FG. Great. So a dot labeled F on the left and a dot labeled G to the right. A straight line from F through G with an arrow at the end here to the right on the far right end. And then here's our ray. Ray FG. All right. So we have a single right pointing arrow on top of those letters, and we named that ray FG. Again, for ray FG, F is the endpoint, drawn as a dot on the left, G is on the ray, drawn as a second dot to the right of F. A straight line goes from F through G with an arrow extending past G. So what's most important for our rays is here for our endpoint, let's make sure F is written first because F is the endpoint, and that's a check on that. Excellent, let's continue on. Use the figure to name each of the following. Number 9, a line that contains A and C. So we want to use the figure to name a line that contains points A and C. Now a line that contains both A and C will go through both of them. In the figure here, we can label A and C, and we can put B right there in the middle. So in the line AC, all right, let's take a look here at number 9. A line that contains A and C. So let's use the figure here to name a line that contains both points A and C. Here's our figure. Now, a line that contains both A and C will go through both of them. In this figure, line AB passes through A and also through B, but we want one through A and C. So looking at the figure carefully, a line through A and C would be our answer. We can name it line AB if line AB is the same straight line that goes through C as well. Let's check. Yes. Line AB there will go through C. So one possible answer here is line AB. Now, line AC or line CA also would be correct. They all describe the same line. We'll keep that in mind. Now, number 10. A plane that contains A, D, and C. So from our postulate 112, 3 points name a plane. In this figure, the parallelogram itself is a plane that contains A, D, and C. We can name the plane by any 3 of those points. One way would be plane ABD. Another way would be plane ABC. Another way would be ACD, etc. So one possible answer here is plane ABD. All right, let's answer numbers 11 and 12. These will be the last 2 we'll answer together in this part 1 of our exercises. Number 11. We're sketching a figure that shows each of the following 3 coplanar lines that intersect in a common point. Let's take a look at our figure. We want 3 lines drawn at different angles, all crossing at the same single dot on one flat surface. So it'll look like a star or an asterisk shape. Here we are. 1, 2, and 3. Great. Now you can add a parallelogram around them if you'd like to indicate that they all lie on one plane. That's not necessary. It's not required of the problem. But the 3 lines all meet at one point. They're all lying flat in the same plane, and they're drawn at different angles, kind of like the spokes of a wheel on your bicycle, those bicycle spokes. All right, now let's take a look at number 12, 2 lines that do not intersect. So on our piece of paper, we want to draw them parallel to each other. They don't have to be perfectly parallel, but they must never intersect. So on a piece of paper or 2-dimensional flat piece of paper, it's easy just to go ahead and try to write them as parallel as possible. So we have a straight horizontal line. That will be line AB. Let's go ahead and write that out, line AB. And then right below that, we want 2 separate points to show these are not the same line. So CD will work, line CD. So we just want to make sure that these 2 lines never touch. They're parallel looking straight lines drawn one above the other. Both have arrows on both ends. They never cross. All right. We will stop here for part 1, and I'll be back soon with part 2, where we'll jump straight into numbers 13 through 15 in our practice and problem solving. We'll see you guys soon. Bye.